Hi, my name is Celine Schneider, and I'm in charge of the NMR facility with CCART. Today, I'd like to quickly introduce you to some of the many things that can be achieved with this wonderful technique within our facility. First, let me give you a tour. The NMR facility is part of CCART, the Center of Chemical Analysis, Research and Training. It is a shared scientific platform, making it accessible to any department on campus, but also to other academic or governmental agencies or private companies. Our goal is to provide in-depth training to research students, research support, and expertise, as well as troubleshooting. The facility is currently located on the first floor of the chemistry building. It currently hosts 3 NMR systems at 3 different fields. The NMR 300 is our smallest yet most used instrument due to its ease of access and versatility. It is equipped with an autosampler and a broadband probe, which allows for the observation of a wide range of nuclei. Both undergrad and grad students have access to it for routine experiments. Next is our NMR 500. The higher magnetic field and inverse probe allows for the better resolution in proton, making it an excellent tool for larger, more complex compounds. It is also accessible to both graduate and graduate students. Finally, the NMR 600 is our most complete instrument. It is capable of running solutions, solid state, or even microimaging. The highest field and versatilities allows for a wide range of materials to be researched, from protein and inorganic solid characterization to biological system studies. Due to its complexity, only a few highly trained students are allowed to use it hands-on, but its access is still possible to anyone through service. So, why NMR? Well, nuclear magnetic resonance is an analytical technique used to determine the molecular structure of a sample, as well as its purity or concentration or behavior. With mass spectrometry, it is an essential technique of the chemist's analytical toolbox to identify compounds. Samples of various natures, such as organic or inorganic molecules, protein, polymers, are run in solution with a combination of one-dimensional and two-dimensional technique to obtain structural confirmation and molecular assignment. Nuclei routinely observed are proton, carbon-13, phosphorus-31, fluorine-19, and for protein, nitrogen-15. But more unusual nuclei can be observed. Basically, if a nuclei has a nuclear spin and a reasonable abundance, it can be observed by NMR. Our NMR 300 is equipped with a broadband probe, which allows the observation of any nuclei with a frequency between 20 and 282 MHz. Some examples run in our facility are shown here, such as phosphorus-31 NMR or 11 boron, lithium-7 at variable temperature here. Other physical properties of a molecule can be observed and even used by NMR. One of these is the self-diffusion property of a molecule. The diffusion rate can be observed and measured by NMR and can be used at various hands. It can help in determining the size and consequently the shape of a large compound. Since molecules of different size will diffuse at different rate, it can be used to separate different species in a complex mixture. Or it can be used to study protein aggregation, for example, an important biophysical phenomenon. Diffusion NMR is a great tool for the study of polymer, complex mixtures such as soil, oil, natural extract, biological serum, proteins, or drugs. Since we're talking about the study of complex systems and its separation by diffusion, NMR-based metabolomics is a hot topic these days. Although not as widely used as mass spectrometry, it offered many advantages. It can be run in vivo. It is a non-destructive technique. Metabolomic pathways can be followed, and NMR can determine the structure of an unknown in your sample. Within CCART, we have looked at the metabolomics or umeoics of decomposed organic matters. We looked at oils and biological tissues, and we are open to any other projects. Now, a dear subject of mine and less known aspect of NMR. Using specific probes, static or magic angle spinning NMR of powder samples can provide structural information as well as distance, angles, or dynamics. Samples that cannot be dissolved or that simply should be studied in their natural state are perfect candidates. For example, here at MEN, we have looked at metal-organic frameworks, amorphous compounds, soils, proteins, and tissue. When looking at an amorphous material, in this case, sporopolylene, solid-state NMR is the only technique to give us some insight into the structure of this complex material, insoluble material, should I say. It is also extremely useful to use MAS NMR of multiple nuclei to, in this case, using REDOR, to determine the distance between the host molecule and its guest. And finally, something new but very exciting to us is the use of solid-state NMR for the study of biological tissue with the intent of metabolic analysis. Last but not least, the CCART facility is the host of a tiny MRI right here at MEN. It is our microimaging probe. We can look at imaging data the same way we do at the hospital on an MRI. We can get spectroscopic data from imaged voxels. We can get T1, T2, or diffusion contrasting. Our only limitation is the size of the sample. It's much smaller than your hospital MRI, which has to be smaller than 10 millimeter in width, which means that basically we can look at tissues as shown here. This is a fixed mouse brain that we ran a few years ago in three-dimensional imaging. We can look at fish eggs. I think there is a huge potential here in the observation of in vivo fish development. We can look at plants. We can look at materials such as diffusion through membranes or pore size. Anyway, there's a huge potential here in terms of that probe. So finally, what I'd like to say is contact us. We're here to help. There are many things that can be done with our instrumentation and the NMR technique in general. So if you have any crazy project and you don't know where to start, call me, send me an email. I'm here to provide you with my expertise in NMR at any level, and I'd love to hear from you. Thank you for listening to my talk. I hope you enjoy it, and if you have any questions, please go ahead.